Okay, the blood and money problems that I'm having you guys do. One's about medication in a patient's blood, and the other one's about bankruptcies. And different years, that's why it's called blood and money. Nothing, anything more complicated than that. Okay, so for blood and money, some patients get a medication. They have to wait a while before it starts to take effect. And so the amount of medication in their bloodstream is here. The time since they took it is here. And this is the equation that you are using to model that. Notice that it is a third degree equation. It's cubic. Okay. And T in this situation is the time in minutes since the drug's injection. You can think of that as your X. You're plugging in how many minutes into all three places to get your answer out for how much drug is in their system. Now this on a domain of 0 to 140. That is your minutes. Okay, so this is your minutes right here. 0 to 140 minutes. So when you're thinking about the domain for this, you're thinking about along the x-axis, and it's saying from minute 0 until minute 140. That's the graph you're making. And so you'll just plug it into your calculator, make a graph. There you go. Don't use my graph. Just made that up. Then it asks what the drug's maximum concentration is in the bloodstream. That you should use your calculator, and you should use the second trace. And then maximum. Use that, that will find your maximum thing, and you're looking for the X and the Y, or actually just the X for the maximum. Down here, it says the drug is effective when its concentration is at or above 70 milligrams per milliliter. So it asks for what length of time is the concentration at or above this level. Well, there is 70 right there. And so you're just going to look at your graph and see how long from here to here was it above that line. Again, don't use my graph. I'm just making stuff up there. Here on the given domain, so in other words, for those 140 minutes, there is only one maximum. And it's asking you, why do you think a cubic function is used to model this relationship instead of a quadratic function? So if I were you, I would see what a quadratic function looks like versus a cubic function, and you tell me why you think the cubic's being used. Also, why must the domain here be restricted in the problem situation? What does the graph of this function right here do that means that it's not going to be good for something over 140 minutes? And that is page 1. Over here on page 2, you're doing the same sort of thing with this one. So we've got number of bankruptcies filed for time in years. So this is after 8 years, 10 years, 12 years, and so on. And this is our function for that, with some big numbers and some really small numbers in it. And notice that it is 4th degree, so that is a quartic function. And what you are plugging into X is the number of years since 1980. So if you plug a 2 in, you're dealing with 1982. And we're worried about from 1988 to 2001, so from year 8 to year 21. And you're just going to sketch the graph up there and then use the function to complete the table. So you can just plug these numbers into the function, or you can put If you're using the TI-84, you can plug this into y equals or in your calculator and just go second graph and get the table right there. Now, when it says, according to the table, between which years, pair of years did the number of bankruptcies appear to be growing at the fastest rate? Well, if this is, say, 1, and this is 2, and this is 3, and this is, say, 17, and this is, say, 19, and this is 20, you can see that the biggest jump is here. So what you're looking for in this, that's when it would be growing fastest, because in 2 years it gets 14 more. That's the most it changes. So that's what you're looking for over here. And according to the model, in what year did the maximum number of bankruptcies occur? How many bankruptcies were filed that year? So again, you are going to use second brace and then maximum, and use that to find the maximum point on your graph. You may have to zoom out a fair amount before you can see the maximum for this. On the given domain, it has only one maximum. Okay, so over those from year 8 to year 21, it only has one maximum. Why is a quartic function used instead of a quadratic? What does the quartic do that the quadratic doesn't? And then using this model, evaluate B of 6 and B of 24. In other words, you're plugging a 6 into the function and you're plugging a 24 into the function and you're putting those there. What do you think those values indicate about the function model? And then don't worry about this, go to page 2. That was supposed to be on page 1 to remind you to go to this page. There is no page 3. Very good. So I hope that you all have a very good day.